Welcome back to the radio room. Back to looking at the Powerwerx SS 30DV that we were looking at in the previous video and didn't have a whole lot of luck getting it working again. Got to thinking, finished up working on that late last night and it was kind of stuck in my mind overnight and this morning. And I wanted to see. The thing ain't working. Let's see if we can try something to get it to do something. And I got to thinking, well, maybe that resistor isn't the right value. I did do some testing earlier, just straight to the pin that resistor is going to, which is the VCC for the TL494 IC. And I got to thinking, we couldn't get the value of the resistor, and there's absolutely nothing out there about this power supply. You can get an owner's manual. It doesn't have a schematic in it. Any of the troubleshooting that's in it is basically, check the fuse, check to make sure you're not pulling too many amps off of it. And if there's anything else wrong with it, send it back. Well, we're not doing that. So, I got to thinking, well, I need to find a way to see if I can get this thing to start with a different value of resistor. And if you remember, we had to take that one board out in order to change that resistor and that one ceramic capacitor and the other electrolytic. And that didn't seem like a really great idea to randomly put resistors in there just to check it, taking that board in and out and in and out and in and out. So my thought was, and if I can find it in this mess, because it has been a pretty well, there's stuff going everywhere out here. I was just getting into it and wasn't cleaning up in between, so to speak. So I grabbed this is actually an old, I think it's out of an old CB. It's like volume control or squelch control or something. It's just a potentiometer. It's a 10K potentiometer. Full resistance is 10,000 ohms. So I figured, well, we can just start this at 10,000 ohms. I'll hook it up in there, and you'll notice I got two wires here. I had this soldered to those wires earlier. Flipped it on and I started at 10K and started turning that resistance down until I started getting output. And then I started getting output and it didn't seem real stable, so I kept coming down. And when it got to about 14 volts, according to the output, that's where I stopped. And it didn't really matter if in fact, I went all the way down to 0 ohms and it was still right at 14 volts. So maybe that resistor isn't necessarily even required. Like I mentioned, in the MFJ version of this, it's just got a jumper in there. And I thought, well, maybe that's because it's got the variable on the front. So I played with this and tried to get it right about 13.8 and didn't have a whole lot of luck on that. And this might be just, it's not, the resistance was varying just a little bit. Heck, it could have been the wires even. But I got it to stabilize right about 14.02 volts. So after I did that, I unsoldered this and then measured the resistance that I had in there, and it came out to like 1.3K ohms, give or take. So I figured, well, let's put a 1K resistor in line and see what happens. So I did that, and right now there's a whole bunch of resistors right here. They're just the tape package of them, and I just tack soldered my two wires that I had on my potentiometer onto one just to test this. I didn't feel like taking it off the strip. If it wasn't going to work, I can just untack it, and that resistor is still good for the next project. And once I did that, I flipped it on. I do have the fan hooked up, because typically when you turn these on, the fan will come on and then it'll just shut off until it's needed again. So I flipped the switch on, the fan came on, and I tested the voltage, 14.02 volts, same as I had with the pot. So then I was like, well, okay, I'll test the voltage with it under some load. To begin with, I just plugged in a little muffin fan that I have that had power poles on it into the front, and the voltage stayed, but I mean, we're not really pulling anything on that. Milliamps. So what you'll notice here is I got two automotive bulbs here. They're 3157, so they're two filament. You know, this is typical probably late 90s, early 2000s, everything. In fact, a lot of vehicles probably still have 3157s in them that aren't LED now. So you got your brake light filament or turn signal and in your park light as well. So I got it wired up so that I'm using both filaments on both ones, and they're in parallel with each other. And I wanted to see if the power supply would stay on with something besides just a fan, little fan blowing on, or hooked up to it. And I did that, and I kind of got it precariously wired right now. Right now I got my meter in amps because I wanted to find out how many amps it was. And here in a moment we'll probably switch back over, but I'm going to go ahead and turn this on, and we're going to see if the light bulbs light up. They should. They did it earlier. I'll also make sure the fan comes on momentarily. And we're going to do this very carefully because it's kind of a very precarious situation right here. I don't know if the other view... Yeah, I mean, we got stuff hanging off this thing and everything else. So we're going to go ahead and try this out and see what happens. So I'm going to carefully try to turn it on. I really got everything in my own way. Okay, so the fan came on. Now it's shut off. And now I'm just going to ground this one wire, and the bulb should come on. And this is pretty bright here, so it's probably going to be pretty bright for y'all too. And let's see if it comes on. So that's got 5.4, let's call it 5.42 amps pulling off of it right now. It seems to be staying pretty well. Let me rearrange this just a little bit, and we will check the voltage while we turn the lights on to make sure that the voltage doesn't drop down too much. I mean, if it drops down, a few hundredths of a volt or something, that's not a problem. So let me just get this rearranged so that we can test the voltage while it has that 5.5 amp load on it. Doing this really carefully, hooking the positives up, and then I just need to hook the negative up so we can measure the output voltage. Which is really kind of hard to do. You'd think there would be an easy place to find. Well, let me shut this off just in case I accidentally. I don't want to accidentally go between the positive and the negative while I'm trying to get this negative probe in here. Just going through the original hole that had the output wires on it. I can get it to stay. Okay, so if I got that connected, let's see here, we got positive, here's my negative, back over on the appropriate one there, 20 volt. So let's go ahead and turn it on and see what the voltage is. So 14.02 volts. Now we're going to put about 5.5 amps of load on it and see what the voltage drops to. 13.9495. So I'm going to call that probably a good deal there, because that's basically what it was staying at before, even with the fan that I had plugged into it. Comes right back up. So that might be just a touch higher than what it was putting out before. I don't think it's going to be too much. That's 0.2 volts. 14 volts shouldn't hurt anything that's plugged into it. I mean, 13.8 to 14 volts. We're not talking a whole lot of difference there. So I'm thinking that's going to be a good solution for it. Now I just got to get this 1000 ohm resistor back on that board and put it all back together. Put some hot glue on it, and I think we're going to be in good shape here. It's not sitting here just buzzing at me. In fact, I don't really hear anything coming off of it right now. This resistor is maybe mildly warm. I mean, you got to sit there for a second to decide if it's actually warmer or not. So I think we're good there. So I just need to get that back onto that board, but I'm gonna have to take the board back out in order to do that. Let me pause a moment. I'll get this mess out of the way, and we'll see about putting that back in, and then we'll get the thing put back together and test it again once we've got it all back together and in its case. So give me just a moment. Okay, so let's go ahead and see if we can get this board back out of here. I'll get these wires removed. Remember from the last video, I got to be careful with this one because that trace is already coming apart. See if we can't get the get this 1000 ohm resistor back in place with it. I just got to be careful, make sure I go through the trace that's already lifted. Down to there. I'm just going to go right there like that. Let me get this soldered in here. Okay. Alright, and I did leave it just a little bit off the board so that it's not right up against the board. Maybe get a little bit of air around it. If it starts getting warm, maybe you can get some air around it. The way this fan works is the fan on the back doesn't blow in. It actually pulls air out, best that I can tell. So there's two vents on the sides. Oh, the air actually goes in through. So, but got that back on there, right there, and just sitting a little bit off the board. And we'll see if we can get it back into. Let me trim these off real quick. Let me shift our view as well. And I'll have to probably put some hot glue back on this when I finally get it done. We'll check to make sure it's working okay before we do that. Gonna get a couple of pins done. I can flop it over and it'll be a little easier to work on. Okay, I'm going to, of all the times I've taken that on and off, we've got a lot of flux built up there, so I'm going to clean that flux off just with some isopropyl alcohol and a Q-tip. Alright. Okay, so before we can go too far back together with this, I do need to clean this hole out right here, where the positive goes in, so I can get the wire back through there. So I think I'm just going to see if I can suck it off of there. Clean this up a little bit. If it'll heat it enough. And that should work. when I undid those, I actually used the soldering gun to get enough heat to heat the wire, the solder, everything else. So I might have to use the heat gun again, or the soldering gun, to get that back together. So that's probably going to be one of our next steps. We're going to see. Let's go ahead and check this thing, make sure it's working. I do want to put this back in here. It's just sitting in there for the moment, but just make sure it doesn't rest up against anything. So we need to, we'll get our cord back out here. Plugged in, make sure it's turned off. Our voltmeter out here. I'm just going to use the regular probes. Get the fan. I'm going to hook the fan back up. And we will check to see if there's voltage. So let's see here. I want to make sure I can actually get to these. Yeah, I should be able to get to those, no problem. So let's go ahead and turn it on. Fan came on for a moment. And 14.03 volts. So I think that's going to work. We just got to get it back into the case. And I think we're going to be good to go. 5.5 amps. It is a 30 amp power supply peak. 25 amps continuous. I don't really have anything to just test it at 25 amps. I probably need to build me a load, DC load sometime, just to test out power supplies. Probably a variable one. I'll come up. There's a few designs out there, and I'm sure I can come up with one pretty easily. I think the hardest part is just getting something that's going to dissipate that much wattage for an extended period of time. So, you know, talking, you know, some pretty beefy resistors or something to get that going. But let me go ahead and see if I can't get this thing back into the case, put back together, and then we'll take a look at it once it's all back together and double check out to the binding posts there and here to make sure we got plenty of power and make sure it's still working. So let me get this back together and then we'll come back right back to that. Okay, so I've got the power supply put back together, got some hot glue holding that board stabilized in place, and got the DMM hooked up to the binding posts on the back, got them soldered back in, of course. It's plugged in, ready to just turn it on and see if we're getting about that 14 volts as well still. So here we go. Okay, fan cycled, and we've got our 14.02 volts just like we had before. I think that's going to work just fine. Most anything that you're going to plug into a power supply is probably going to be just as happy at 14.02 as it is at 13.8. We're talking, you know, basically less than a quarter of a volt here. Your alternator in your vehicle puts out more than that when it's charging the batteries. So I think we're going to call this a win. If this one has any more problems in the future, I'm guessing it's probably, I mean, it's likely. I don't know if when that resistor was damaged, that capacitor was damaged, if anything else was weakened in the supply. or if it caused any other potential future, failures to be a little quicker than they normally would be. But it looks like it's working. Get it back to the owner and see if he wants to use it. I think he already bought a new one to replace it. But this one might be a good one for standby. It might be a good test to just put something with a little bit more load on it to make sure it's going to work okay. But I think we're in good shape. I think really maybe that resistor just went, probably maybe because of that capacitor was leaking over there to ground. So Powerwerx SS 30 DV putting power back out again. Thanks for stopping by the radio room. We'll catch you later.